Hello, this is Alan with a problem about impulse, acceleration, and rockets. The problem reads, a model rocket of mass 0.25 kilograms is launched vertically with an engine that is ignited at time t equals 0, as shown above, or in this case, below. The engine provides an impulse of 20 newton-seconds by firing for 2 seconds. Upon reaching its maximum height, the rocket deploys a parachute and then descends vertically to the ground. So you can see here, time is 0, the engine ignites, time is 2, the engine stops, maximum height, the parachute deploys, and the rocket descends. And it's important here that the figure is not drawn to scale, so we can't just measure all of these and see what the difference is. So the first part of this problem, on the figures below, draw and label a free body diagram for the rocket during each of the following intervals. First one, when the engine is firing. So in this case, because we are on Earth, there is a force of gravity going down, which I will call Fg. Because it's a rocket, there also is a force going upwards, which I will call Fr. Next, after the engine stops, but before the parachute is deployed. So at this point, there's gravity going down, but nothing going up, so that's all there is. Lastly, after the parachute is deployed, well now, there's the force of gravity going down, but there's also a force going up. And this is not friction, as in air friction, but the tension in the ropes. So now, determine the magnitude of the average acceleration of the rocket during the 2-second firing of the engine. So, we know from Newton's laws that the sum of the forces equals m times a. And in this case, the sum of the forces also equals Fr minus Fg. So, lowercase g, just to keep it consistent. To find Fr, we know that the impulse, J, equals 20, as given above, and that equals the force over time. So, time is, you can divide both sides by t. T equals 2, so the force due to the rocket equals 20 over 2 equals 10 newtons. Force due to gravity equals mass times acceleration due to gravity, which equals 0.25 times 9.8, which is 2.45. So, using this equation, mass times A equals 10 minus 2.45. You can divide both sides by m. M equals 2.5, so minus 2.45 is that, divided by 0.25 equals 30.2. So the final answer, 30.2 meters per second squared. Because again, this is the average acceleration, and we do need the units. Next part, what maximum height will the rocket reach? Well, because the rocket is accelerating upwards with the force of the rocket, and then is not, we have to do this in two parts. The part where it is accelerating with the rocket, and the part where it is not. For the part where it is accelerating with the rocket, we can say that we can find the final velocity right before the rocket stops by saying v equals v naught plus at. Well, and solving for v. Well, v naught is 0. A we found earlier to be 30.2, and t is 2, so that equals 60.4. Then, using another of the kinematic equations, v squared equals v naught squared plus 2a delta x, and yes, by delta x I do mean upwards and downwards. We can solve for that, so delta x equals v squared minus v naught squared over 2 times a, and that equals 60.4 squared minus 0 squared all over 2 times 30.2. And that equals 60.4. Same thing as the acceleration. Although that isn't always the case, it's just, in this case, it is. That's only for the first part, though, when it is accelerating with the rocket. After that, the acceleration is only due to gravity, 9.8. So then, using this same equation, and knowing that when it's at its maximum height, then velocity equals 0, we can say that delta x equals 0 squared minus 60.4 squared, because 60.4 is when the rocket stops, meaning so when the first section ends, the second section begins. All that over 2 times negative 9.8. So, you get approximately 186.13. Add these two together, you get 246.13 meters. As the total height that it will go. Final portion of this. At what time after t equals 0 will the maximum height be reached? Once again, this will have to be done in 2 sections. The first section, t equals 2. That's given to us. The next section, we can use v equals v naught plus at, and use v as 0, v naught as 60.4, a as negative 9.8, and solve for t. So from that, t equals negative 60.4 over negative 9.8, which equals approximately 6.16. But again, there's the time for the first section, then the time for the second section. Add those together, you get 8.16 seconds as the total time. And that is how you solve this problem. Thank you. Bye.